All right. So the quadratic formula and the discriminant, which is a piece of the quadratic formula, we'll see that in a minute. Um, Quadratic formula, you've sort of seen it before, probably in middle school. They might have even sung a song to the tune of Pop Goes the Weasel, which you won't hear from me. But the quadratic formula is amazing in that it can solve any quadratic equation. All right, so we've been talking about graphing them to solve them, factoring, just solving when we can. All great methods, but all limited. The quadratic formula is unlimited. Okay, it can solve all of those. So why didn't we just tell you this one from the beginning? Because there's a lot going on here. It's not difficult, but there are a lot of places and a lot of opportunities for mistakes. So a lot of the things we've been doing, there's only like two or three operations that we're doing. You can see here we've got many. We've got the negative in front of the b. We've got two operations here. We need to add and subtract after we take the square root of this squared minus this, and then we have to divide it all by 2 times a. All right? So how it functions, not that difficult. We look for the a, which is always in front of the x squared, the b, which is always in front of the x, and the c, which is always the constant. Now notice, for the quadratic formula, we want everything on one side equal to 0. All right, that's how we start solving for the quadratic formula. And then we literally just take wherever there was a b, I need to plug the b in. Wherever there was an a in the formula, I need to put an a in. I would highly suggest using the parentheses, especially in the beginning, until you get used to it, because that's where most of the mistakes happen, is when we try to skip using the parentheses. All right, so here's an example. We've got this one, and you can see, first thing we needed to do was identify the a, b, and c. All right, so if I start looking at this, get some color here. All right, remember the a is in front of the x squared, so in that case it was a 1. The b is in front of the x, that's the -2, and the c is the constant, which is -8. So it does keep whatever signs in front of it. And then you can see we're substituting it in. So the b's were both -2, the a was a 1, and the c was a -8. So you can see, not tricky, the formula, and then you just put in where it's supposed to go. This is where the mistakes happen. Like this, minus a -2, a lot of people will forget, and they'll just end up with a -2 instead of what's going to be a positive here. -2 squared, they'll punch it into their calculator without the parentheses and get -4, but it's actually +4. These three pieces all need to be multiplied together before subtraction because of order of operations. And a lot of times people will do this, then subtract 4, then multiply by 1, and multiply by -8. And then dividing the whole thing by 2 after you're done, and knowing that the two solutions, a plus and a minus. So like I said, this is where things can get really dicey. All right, so I think I'm going to add a few more steps in on this one really quick. Okay, so right here, -2 squared, that was a 4. So this is actually square root of 4. And 4 times 1 times -8 is -32. Or you can think of it as -4 times 1 times -8 is plus 32. Either way, we get this 36. That's where they got their 36. But notice we had to do this piece and then subtract it from this piece. So like I minus a -32, if you will. But whenever I have a negative and a negative, I know I'm going to get the positive, which is where we're at. And 2 times 1 was 2. A lot of people sometimes just forget about this part altogether. They're just working the top and they get two great answers. Like this one would be 8, and this one would be -4, because they've forgotten this 2 along the way. So you always have to double check. 8 divided by 2 is 4. Notice, sorry, the plus and minus. That's how we ended up with two different cases. We had the plus and we had the minus. That's what that plus and minus means. Because square root of 36 meant 2 plus or minus 6 over 2. And that's how we get those two cases. All right. And our answers are both of these. X equals 4 and x equals -2. So if we're looking at a graph of this, this means that it should be crossing at x equals 4 and x equals -2. Also, you might be looking and saying, hey, this actually factored. Okay, this would have factored to x minus 6, hold on, x minus 4 times x plus 2. All right, because two numbers that multiply to -8 and add to -2. And you could see if we did zero product property, I would have had x minus 4 equals 0 and x plus 2 equals 0. So I'd get x equals 4 and x equals -2. And this is a great example of why we taught you the other methods. Because this, you might be like, well, why did we just waste all that time on the quadratic formula? Because this will work when other things won't. Like if it didn't factor, you don't really have another method here. But you do now with the quadratic formula. It doesn't matter whether this factors or not, it's going to give you your answers. All right? So here's one for you to try, so pause it if you haven't already. I will say, notice the first thing here, it's not ready to go yet. We had to write it in standard form. So to write that thing in standard form, first thing I needed to do was make this a 0. To make that a 0, I subtract 21. And of course, our rule, if we subtract 21 from one side, we have to both sides. Now, these don't combine. That's why it's just kind of tacked on to the end. And now we can see our A, B, and C. So for this one, we can kind of see our A would be the 1, the B is -4, and the C is -21. And I'm going to actually click this out so I can write on it and it won't disappear every time. So once again, the number in front of the x squared, it's not there, so that means it's a 1. And B was -4 and C was -21. And you can see that's what they did. The B's and then the A's were there, and then the only place C goes is right here. That's the only time that shows up in the formula. All right, and they didn't do it. Let me do it really quick. -b plus or minus the square root of b squared minus 4ac all over 2a. That was our quadratic formula. All right, so that's what they used here. Now, once again, this is where most of the mistakes occur, right in here, getting from this step to this step. So let's take a closer look. -4 squared is 16. 4 times 1 is 4, times -21 is -84. So 16 minus a -84 is 100. All right? And square root of 100 is 10, and then we do plus or minus. So you can see here, plus or minus, we have our plus and we have our minus. That's why we have two separate equations from there. Okay? 4 plus 10 was 14 divided by 2, which is 7. 4 minus 10 is -6 divided by 2, which is -3. All right? Which means this should have factored, working it backwards, it should have factored to -7 and +3. Two numbers that multiply to -21 and add to -4. All right? But once again, we're working on the quadratic formula here because it will work even if it does. Maybe it factors, but you can't see the factors. Then you can go to quadratic formula and it will work. All right? Just have to be careful. All right. One of the things about the quadratic formula is this discriminant. Sometimes this can save you from even having to do the problem. Okay? Because we're dealing with real numbers in Algebra 1. All right? We don't get to complex numbers till Algebra 2. All right? So that means we don't do square roots of negatives. All right? When we get to Algebra 2, we'll talk about what happens if this is a negative. For us, if this is a negative, we just say there's no real solution. So once again, this is called the discriminant. Based on the discriminant, we can tell if it has 2, 1, or no solutions. All right? Most of the time, it's going to be this one right here. Hold on. Most of the time, it's going to be this one right here. 2 solutions. And that's when the discriminant is greater than 0. That means the discriminant is positive. all right, which is most of the ones we've seen, like 36, 25, 11, all of that. If the discriminant was 0, then that means it doesn't matter whether we add or subtract it, right? Because square root of 0 is 0. So if you add 0 and subtract 0, it doesn't make a difference. So that's why we have one solution, one real solution. And then if this is negative, like we've been saying, okay, we don't do that yet. So negative, it doesn't cross the x-axis, so we say no real solutions. All right? There are solutions, and we'll talk about those in another class. But as far as real solutions, where we actually have a real number, meaning it's crossing or touching the x-axis, okay, if the discriminant is negative, that isn't occurring. All right. So once again, here's an example. First thing I have to do, once again, standard form. My goodness, I've missed a whole lot of questions due to this, because I'll just start looking, oh, b is -3, c is -5. No, it's not. C is a +5. And that's important because the discriminant is b squared minus 4ac. Remember, that was the part that was underneath the square root symbol for the Pythagorean theorem. All right? So this was negative, and remember we said negative. We don't do square roots of negatives yet, so we do no real solution. All right? There is a complex solution, but we don't worry about those yet. All right? So we're going to try one for you. So pause it if you haven't done this yet. Once again, same kind of trick here. Not trick, but just to remind you, we've got to have it in standard form so to get this to be a 0, I subtracted 7 from both sides, and you can see when we subtracted 7 from both sides, I end up with this, and I got my 0 I'm wanting. So now I know my A is 6, my B is -5, my C is -7. But remember, I don't have to do the whole thing. It's just saying how many real number solutions. All right, so all I have to do is look at the discriminant. Some of you might go through and do the whole quadratic formula, and you'll still find out, because when you're done, you'll find out, hey, I have 2 solutions, or I have 0, or I have 1, if you did the whole quadratic formula. But since they didn't ask what the solutions are, they just said how many. All right, this is positive, and according to what we just learned, if the discriminant is positive, then there are 2 real number solutions. All right, I hope that helps.